Hello and welcome to another NGen Math 8 lesson by eMATHinstruction. My name is Kirk Weiler and today we're going to be doing Unit 3, Lesson 9, Transformations and Congruent Figures. All right, so we've talked about transformations a lot and we've talked about congruent figures, two figures that are identical in both their shape and their size, but they just happen to be in different places in the plane. Right? And we've tried to talk about the connection between transformations and congruent figures, specifically using rigid motions. And let's kind of review that before we jump into exercise 1. So because rigid motions do not change the size or the shape of a figure, if we can find a rigid motion that maps one figure onto another figure, the two figures have to be congruent. They have to be identical. And you'll spend quite a bit of time when you take geometry at the high school level kind of talking about this idea and what sequence of rigid motions will map this figure onto this figure in order to prove that the two figures are identical, are congruent. What we want to work with today is this idea. Now remember, our rigid motions are reflections, rotations, and translations. What we want to do is work on saying, hey look, I know that these two figures are congruent. What rigid motion will map one of them onto the other? Because guaranteed, if there are two objects that are identical, right, that are two geometric objects that are identical / congruent, then there will be a rigid motion or multiple rigid motions that'll map one of them onto the other one. Let's get some work with that idea in exercise number 1. In each graph below, determine a single rigid motion that would map triangle ABC onto triangle DEF, thereby proving that they are congruent. Describe the transformation as specifically as possible. Okay, so let's talk about what all that means. Now keep in mind, we're always going from triangle ABC to image triangle DEF. All right, so let me just bring this up a little bit. Let's take a look at letter A. Here we've got our image triangle ABC and our original, which is our pre-image ABC, and our image triangle DEF. The question is, what could we do to this triangle, a single transformation that would map it onto this one? Well, hopefully it's fairly obvious, which is that we would take this and we would reflect it across the x-axis, right? And when we do that, I can kind of do this if I do what's called a flip, right? If I simply flip this thing across the x-axis, notice that it gets mapped on here. Now, notice it says describe the transformation as specifically as possible. So if you just said it's a reflection, well, that's pretty good actually. Just knowing that, okay, this triangle gets mapped to this one using a reflection, that's pretty awesome. But it's not as specific as possible. In fact, the most specific thing that we can say is we can say a reflection across the x-axis, right? A reflection across the x-axis. And that's it. That's as specific as possible. Let's take a look at letter B, all right? In here, we've got our image triangle ABC, right? Our pre-image triangle ABC. I'm going to see if I can mess up that terminology on every problem. And then the image triangle DEF. The question is, how do we map, using a single transformation, this triangle onto that one, right? Well, it's not a reflection, because if we flip it across the y-axis, right, that's not going to happen, or certainly across the x-axis, that's not going to happen, right? It's probably not a translation either, right? Because if I took this thing and I simply kind of slid it, right, left, up, down, or anything like that. Now I want to get it back to the original spot. That is also not going to map it there. But if I rotate it, in fact, if I rotate it about the origin, so the origin is the center point, by 90 degrees counterclockwise, it's going to end up here. All right, now you can test that by simply taking your paper and rotating it. For me, I can literally test it by simply rotating my entire image that 90 degrees counterclockwise, right? So if I'm rotating it 90 degrees counterclockwise, then it gets mapped to the image. So how do I want to describe this? I'm going to say a rotation by 90 degrees counterclockwise, and it is important to put that counterclockwise in, whoops, about the origin, right? A rotation by 90 degrees counterclockwise about the origin. All right, what I'd like you to do is pause the video now and try to work through all the remaining 4 of them. Try to figure out, you might have to turn your paper sometimes to see if it's a rotation. You know, you might have to even use tracing paper, but see if you can describe how to map triangle ABC onto DEF in each one of these different situations. Pause the video now and take quite a few minutes to try to figure these out and write down their descriptions. All right, well, letter C may be the easiest of them all, okay? Notice how this triangle, the image triangle, is more or less in the same what I would call orientation as this one. In other words, it doesn't appear like it's been rotated or flipped at all. In fact, all we have to do to this triangle to map it onto this triangle, whoops, is simply move it to the left by 2 units and move it down 1, 2, 3, 4, 5 units. All we have to do is shift it 2 units to the left and 5 units down. And that means it's a translation. So, in the little bit of room here, I'm going to say it's a translation 2 units left, 1, 2, 3, 4, 5, and 5 units down, right? I just take that entire image and just slide it 2 units to the left and 5 units down. Let's take a look at the bottom row. All right. Whoops, that's not what we wanted. Let's try that again. There we go. So, letter D, right? What do we want to do here to get this all the way over here? Well, that is again going to be a rotation, okay? With the origin as the center point. The key here, though, is that a 90-degree rotation isn't going to be enough, right? That right there would be a 90-degree rotation. But if I keep going, right, another 90 degrees for a total of 180 degrees, then this triangle gets mapped to that triangle. So it's a 180-degree rotation around the origin. But what about direction? We've talked about this a little bit before. Now, in that particular situation, I rotated it counterclockwise by 180 degrees. But the great thing about a 180-degree rotation is it doesn't matter whether you go clockwise or counterclockwise, because a 180-degree rotation is simply a half rotation around the circle. So it doesn't particularly matter which direction you go as long as you're going 180 degrees. So it's actually okay in this case to just say, this is a 180-degree rotation about or around the origin. All right? Now, letter C. This one is definitely a reflection, right? Now, it's not a reflection about the y-axis. If it was a reflection about the y-axis, then point C would have just ended 3 units to the right of the y-axis. It's obviously not a reflection across the x-axis either. In fact, this particular problem, the actual reflection is across this vertical line, right? And you can tell that because this point is 1 unit to the left, and then its image point is 1 unit to the right. Same with letter D, or letter A, sorry. It would be 1 unit to the left, then its image point is 1 unit to the right, and point C, that's going to be 4 units to the left, its image point is 4 units to the right. Now, the hardest part about this is being able to describe this line. That's a vertical line, and remember, all vertical lines have x equals a number equations. And in fact, all up and down this line, everywhere along this line, the x-coordinate is equal to 1. So that's the equation of that line. And in fact, let me just make it a little bit shorter so I have some room to write. What I would say is I'd say it's a reflection across the line x equals 1. All right, finally, this one. right? This one looks all sorts of weird, and it may have really taken you some kind of rotating of your paper to figure it out. Again, definitely not a reflection. If it was a reflection across a vertical or a horizontal line, those are pretty easy to see, and if it was a translation, it wouldn't have changed its orientation like this. In fact, what I can see by turning my paper is that a 90-degree rotation about the origin clockwise this time will map ABC onto DEF. So a 90 degrees clockwise rotation about the origin. All right. So in each one of those situations, we were able to find a rigid motion, i.e. a translation, a reflection, or a rotation, that mapped the pre-image onto the image, therefore showing that the two triangles are identical. Let's keep working with this in the next exercise. All right, exercise number 2. A sequence of 2 transformations has been used to map triangle ABC onto triangle DEF. Letter A asks us, how can you tell using the orientation of the letters that one of the 2 transformations must have been a reflection? All right, now this is a new one for us. How can we spot that a reflection has been done? If there's only been one transformation, just one, it's pretty easy to know whether a reflection is involved or a translation or a rotation. That was the last exercise. But when there are 2 or more, because there can be more than 2, probably not at the Math 8 level, but when there are 2 of them, it becomes much harder. So how can we spot it? And here's something that's really, really cool. If you look at the letters on triangle ABC, if you were to sort of draw a circle around them, starting at A, going through B, going through C, and back to A, those things would go clockwise, right? So like literally, if you did this, right, that would go clockwise in alphabetical order. On the other hand, if you did exactly the same thing to this particular triangle, starting at D, going to E, going to F, back to D, right, that would be counterclockwise. So the orientation, the alphabetical orientation of the letters has reversed, and that will always happen when you have a reflection. So the alphabetical orientation of the vertices has been reversed. In other words, if it started off by going clockwise, right, it changes to counterclockwise. If it starts off going counterclockwise, it would reverse to going clockwise. That does not happen with either a rotation or a translation. And by the way, it's almost identical to literally looking in a mirror. So if you look in a mirror, right, what you will see, your right hand will look like it's your left hand, and your left hand will look like it's your right hand, and likewise, like with the part in my hair should part to the right, but when I look at it in the mirror, it parts to the left, or maybe it's vice versa. Anyway, the point is everything sort of gets reversed in a reflection, right? The object is still the same size, it's still the same shape, but everything has kind of reversed its orientation in a reflection just as it does when you look in a mirror. It's really kind of a neat way to spot when a reflection has occurred. Let's take a look at letter B. Assuming the first transformation was a reflection in the x-axis of ABC, describe the second transformation. All right, well, I'm going to erase all this stuff because we don't need it, and then I'm going to toss my graph grid all over the place. We'll just move it back to where it needs to go. Give me just a second to lock it down. There we go. Now nicely locked into place. Okay, so letter B, assuming the first transformation was a reflection on the x-axis, what was the second one? All right, so we know a reflection had to happen. Let's just assume it was the first one and it was in the x-axis. How can we figure out what the second one was? Well, the best way to answer this question is to honestly reflect triangle ABC in the x-axis, and then see what you'd have to do to take its image and map it to DEF. So pause the video now, take ABC, reflect it across the x-axis, maybe label it A prime, B prime, C prime, that's our favorite, and then ask yourself, what would I have to do to A prime, B prime, C prime to map it to DEF? Pause the video now and take a shot at that. All right, let's do it. So here we go. I'm going to just bring this up a little bit. I'm going to go over to A. A currently sits 3 units above the x-axis. That means A prime would sit 3 units below the x-axis. Same thing with B. It's 3 units above, so B prime is now 3 units below, and C prime would be 1 unit above. So we do that reflection, and we get our new image triangle. Right. Now the question is, what do I need to do to this to map it up to that? And notice these two triangles are really in the same orientation. And what I mean by that is that AB is horizontal and DE is horizontal, and B prime, C prime, and FE, right? All I'm going to have to do now to this is shift it. I'm going to just translate it. The question is, how much, right? And the key to doing that is to pick any one of these 3 vertices, A prime, B prime, or C prime, pick the corresponding one up here and think about mapping it. Why not just think about A prime? Okay, so for A prime, we'd want to map that up to D. What would we have to do? Well, we'd have to shift it to the right. It's currently 6 units to the left of the y-axis. We'd have to shift it those 6 units plus another one. So we'd have to shift it 7 units to the right. Right, that would put my A prime right there. Then I'd have to shift it 3 units up to here, and then another 6 units, so 9 units up here. So it would have to be what? A 7 unit shift, and then a 9 unit shift. All right, so we're going to translate by, just to make sure, 7 units right, and 9 units up. And again, the idea, just to make sure, is all I'm trying to do is describe this vector, right? If I were to map A prime, sorry, that's a horrible looking diagram. If I were to map A prime up to D, that would force me to shift the entire triangle 7 units to the right and 9 units up. All right, now maybe a little bit harder is going to be letter C. Now I've redone the diagram down here, but let's take a look at letter C. Give a sequence of transformations that would map ABC onto DEF, where the first is a translation. Describe the 2 transformations as much as possible. There are multiple correct answers. All right. Now, I know that a lot of students hate it in math when there's multiple right answers to a problem, but then again, it gives you more chances to be right. In the last one, right, we forced you. We said, okay, you're going to do a reflection across the x-axis now. Now what happens now? In this one, what I want to do is I want to do a translation first and then a reflection. So somehow I want to translate this and then flip it across some horizontal or vertical line so it lands here. And there are literally an infinite number of ways to do this. There really are. And what you almost have to do is you almost have to pick the reflection that you want to do. And what I mean by that is even though the reflection is going to come second, right? The reflection is going to come second, right? We kind of want to do a translation that allows us to do the reflection easier. Now, it should be pretty obvious that I'm going to have to reflect, right, across a horizontal line, right, before I do my translation. Or sorry, I'm going to have to reflect across a horizontal line. All right. Perhaps I'd like to reflect across the x-axis. So the question is, how would I have to move this so that when I then reflected it across the x-axis, it landed on that? Well, let's take a look at that issue. Right here we've got D right up here, and where's D at? D is at the coordinate point 1, 6, right? If I want A to go across the x-axis and land on D, then A prime, right, wherever that thing lands, has got to be at 1, -6. Right, this is where my A prime must end up. And if my A prime ends up right there, then when I flip it upwards, right? It will land on D. So what do I have to do to take this thing and translate it down there? Well, to map A down to here, I'll have to move 7 units to the right. So let's translate 7 units right. I cannot get that to right. 7 units right. And I'll have to make it go down 3, 5, 9 units. Sounds familiar to the last one. And 9 units down. And when I do that, everything else will kind of come along for the ride. In other words, B prime will end up there, and C prime will end up there. Now, once I've done that translation by 7 units to the right and 9 units down, then when I reflect across the x-axis, it's going to land on triangle DEF. So there's my first one, and then a reflection in the x-axis. Come on. Now, again, there's lots of different ways to do this. Another way to do it would have been to actually map A right to D. Literally, to slide this triangle up so that suddenly it was sitting like this. Right? So I could easily take this triangle and shift it. I think it would be 7 units to the right and what? Another 3 units up, and it would have been sitting right here. I would have then had to reflect, though, across this particular horizontal line, right? Which is the line y equals 6. And that would be fine. I could do that. I could say, okay, so first thing I'm going to do is translate 7 units to the right and 3 units up, and then I'm going to reflect across the line y equals 6. That works fine. That's where I'm saying that you have to almost decide on what reflection you want to do first before you decide on the translation that kind of sets you up in order to do that. All right, let's summarize. Actually, we're not summarizing. We've got another problem. Here we go. Exercise number 3. Triangle DEF is the image of triangle ABC after a rotation of 90 degrees counterclockwise, followed by a translation. Draw the image of triangle ABC after the rotation. Label this image triangle A prime, B prime, C prime. All right, great. So again, note, what we're doing is we're telling you triangle DEF, this one, is the image of ABC after a rotation by 90 degrees counterclockwise, followed by some translation. Notice translations get involved in a lot of these things, right? So the first thing that we ask you to do is take this and draw it after a 90-degree rotation counterclockwise about the origin. Pause the video now and do that, and then we'll figure out what the translation is in letter B. All right, let's do it. Well, again, you could go about memorizing some kind of rules, but ultimately speaking, if you're going to rotate an image by 90 degrees clockwise or counterclockwise or whatever, probably the easiest thing to do is literally take your paper, right, turn it, rotate it, 90 degrees counterclockwise. Now what I'm going to do is I'm going to take a moment, I'm going to read off the coordinates of, this is really now A prime, B prime, C prime, then we'll rotate the paper back and we'll plot those coordinates. So, for example, A prime, right, must now be at -6, -7. Then we've got B prime at -3, -7. And we've got C prime at -3, -2. All right, now what I'm going to do is I'm going to rotate my paper back. And I'm going to plot those, -6, -7. Here's my A prime. B prime, -3, -7. And C prime, -3, -2. And there we have it, right? It's a very effective way to do rotations. Take your paper, rotate it, read off the coordinates, rotate it back, and plot. All right, letter B. Describe the translation needed to then map triangle A prime, B prime, C prime onto triangle DEF. Explain how you found your answer. All right, so what I'd like you to do is pause the video and come up with a translation rule that tells me how to translate this so it lands on that. Pause the video now and go ahead. All right, well, let's actually explain it and then do it. We need to pick a single point on A prime, B prime, C prime, and then think about how that point will get mapped to the corresponding point on triangle DEF. You can do almost any point you want. Actually, you can do any point you want. I'm going to choose C prime. So in other words, I'm going to take C prime, and I'm going to figure out what I have to do to translate it to point F. And that's specifically to move it 3, another 5, another 1. So I'm going to translate 9 units right. Let me just check that really quick. Let's see, 3 and another 5 is 8 and another 1 is 9. And then I need to move it up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 5 units up. And explain how we did that. Just translate point C prime to point F, right? And that's it. You know, all we have to do is take this thing, find a single point on it, find the corresponding point on its image, and ask ourselves, how much would I have to shift or slide this point in order to get it up there? And what I'd have to do is I'd have to move it 9 units to the right and then another 5 units up. Another 5 units up. And the great thing is, the rest of the triangle just comes along for the ride. Okay, now let's summarize. So in this lesson, what we really wanted to hammer home was the idea, the connection between congruent figures, figures that are identical in shape and size, and rigid motion transformations, the reflection, the rotation, and the translation, and how we can combine 2 of those to produce images that are congruent to the original, right? Very, very important idea. Any 2 images that are identical to each other, you can find a sequence of those 3 rigid motions, reflections, rotations, translations, that will map one figure onto the other. All right, I just want to thank you for joining me for another NGen Math 8 lesson by eMATHinstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.